All right, this is cycle 2, week 14. We have 2 experiments. The first one is cold feet. So for this, you're gonna need aluminum foil, which is in your science bin. So you're just gonna grab a square, maybe 2 in case it rips, because everybody's gonna be sharing it. You're gonna want a ceramic cup. So bring that from home, like a mug, and then a metal spoon. You bring that from home as well. And then I will have like a hot pot tea kettle going in somewhere in the hallway so you can heat it up. Maybe send a mom out, right before to make sure that it's hot in there. And then you're gonna want a styrofoam cup, and that will be provided for you as well. So right at the beginning, just pour that send a mom out to pour the hot water in both the ceramic cup and the styrofoam cup. And then, we're just gonna tell the kids, that before we begin here, I have, a cup of hot water, and I'm just gonna put this spoon in here, and we'll check it again in a few minutes. So then we're gonna ask them if they've ever seen their mom or their grandma wrap a potato, to bake it in aluminum foil, and ask them why do you think they do that, and wait for their answer. Ask them about the pots and pans that they use at their house and what they're made out of. Is it metal or copper or stainless steel? Ask them if they've ever had like shish kebabs, or those metal sticks where you put on the meat and the vegetables. And just talk about how metal is a conductor of heat. And then talk about how in when it's cold outside, you want a nice warm coat. And so how I have a coat made of wool, but I'm wondering maybe if a coat made of metal fibers, like in our pans, maybe that would be better. Maybe that would keep me warm. So ask them what they think, and then don't tell them the answers. Let them ponder on that, because we'll come back to it at the end. We're gonna talk about 2 new words today: conductor, and the word conductor means that something lets heat and electricity pass through. And the second word is insulator. And an insulator is something that does not allow heat or electricity to pass through. So we're going to talk about how we have this piece of aluminum foil, and you need to be in a room where you have a hard floor, and where you have carpet. Let them kind of get some wiggles out and go around the room and feel that every place in the room is the same temperature. It's constant no matter where they are. And you're going to go over we're going to tell the kids they get to take off their shoes and their socks. And they're each going to have a turn. And what you're going to do is you're going to put this tin foil on the hard surface, the colder surface. And then you're going to ask the kids, by show of hands, how many of you think that the carpet's going to feel colder, and how many of you think the foil is going to feel colder? And let them, raise their hand. And then let them all go through and do that. And after they do that, ask them, how many of you did think the aluminum foil felt warmer to their feet, and how many felt that the carpet was warmer? And then which one you think was the conductor? And again, the conductor is the one that lets heat and electricity pass through. So the conductor would be the foil, and which one was the insulator, the one that doesn't, and that would be the carpet. So you can talk about that, and then also we're going to get back to these cups, and hopefully by now, with your metal spoon and your steaming hot water, that if they briefly touch this, they can feel that the spoon is hot because it has conducted that heat. So you can ask them, if I were going to give you a cup of steaming hot cocoa, hot chocolate, would you rather have it in this kind of a mug to have your hands on? Because I can feel this right now, it's really hot. Or would you rather have it in like the styrofoam? Because when I feel these two, this one has let the heat pass through, whereas this one does not. So you can again talk about the conduction versus the insulator. And then getting back to that coat, should I go buy a coat that's filled with metal? And let them again say yes or no, and why. And the answer is no, because what the metal would actually do would be to pull the heat away from my body. So that wouldn't be a good thing. So better just stick with the wool coat. So that's that experiment, and actually go through that kind of quick because there's another couple experiments, actually like 3, that are kind of fun. So then the next one is called Pepper Run Fireworks. So for this, you're going to need pepper, which will be provided for you. And then you're gonna have small plastic plates. Yours are gonna be clear with each child, and you're gonna fill them. You're gonna just have some water. It doesn't have to be warm or cold or anything. You're gonna fill it with water, so maybe bring a pitcher. And then you're going to have toothpicks. I got my hair. You're gonna have a toothpick for each child. Those are provided. You're gonna have some dish soap that is in your tutor bin, so make sure you bring that. Some whole milk, which I will bring for you that day. You're gonna need food coloring, and that you're just gonna need to bring from home. It doesn't matter what color. You're gonna need Q-tips, and those are provided for you. Pennies, those are provided for you. And some bowls of water and pipette, one for each child, and those are provided for you. And some bubbles, and I do have some bubble solution here that will be provided for you. But you need, if you have a bubble wand or a way to make it, and the bubbles aren't necessary, it's just a little added bonus in the beginning. So you're gonna ask them, have you ever blown bubbles? Well, yes, of course they have. Isn't it fun? And talk about how blow a few bubbles, just as the teacher, the tutor, and let them see how sometimes they stick together and how they pop, and ask them if they've ever wondered how the whole bubble process works. And then, if you were to take that bubble wand and just dip it in regular water, would it make bubbles? No, it wouldn't. And talk about, maybe really briefly talk about why that is, or let them tell you what they think. So we're going to talk about surface tension today. So you're going to ask if anybody can tell me what water is, and they'll say, H2O. And about how the molecules in the water are like magnets, and they want to stick together, and they make little friendships or bonds together, and those little bonds are called surface tension. So the first thing that they're going to do is they're going to take their little plate and their penny, and you're going to have some little cups of water, and they're going to take their pipette, and they're just going to fill it up, and they're going to count how many drops they can fit on. And eventually what it's going to do is it's going to make a dome, and then all of a sudden there'll be just one that sends it over. There it goes. It broke the surface tension. So you can talk about that. Their hypothesis is how many drops they think. Now, the second little experiment in that is they're each going to have a little plate of water in front of them. And we're going to sprinkle some pepper on it, on their plate. And you can ask them, where is the pepper? Did it sink? Is it suspended? Is it sitting on the top? And it should be sitting on the top of the water. And ask them, why it's sitting on the top. And again, it goes back to that surface tension, because the water molecules are all pulling together. And then talk about how that you're going to have these little dishes, or have some little cups with dish soap in it, and they're going to take the toothpick and just dip it in there, and ask them, what do you think will happen when we put this in there? And then let them do it, and what's going to happen is it's going to run. It causes it to pull away, so they'll think that's really fun. Oh, those already, I guess it's just a one-time thing. So the pepper ran away from the toothpick because of this dish soap was what's called a surfactant, and it weakened the bonds, those little friendship bonds in the water. And so the reason that we can blow bubbles with the bubble solution is because that bubble solution has that surfactant in it that makes it pull apart. And then this one I think is so neat, and I hope that you have time for it, that you can make time at the end. And this is just one that you as a tutor are going to demonstrate. You're going to have your plate of whole milk, and you're going to just take a couple drops of food coloring and put it put them in the more in the middle. I just did 2 drops of red, and I'll do 2 drops of green, and they'll kind of sink, but we got 3. And then you're going to take a Q-tip and you're going to dip it in that soap again, and you're going to dip it in. Oh, it's not working. Oh no. Well, it's supposed to, like, fireworks go out. It might be because our milk is not store-bought milk. So hopefully that's gonna work at home. But if you, let's see if we try a little bit more soap, if it does anything. No. So hopefully it will work, because usually it makes this really cool, like, fireworks swirling pattern. So I will have milk for you at home, and you can talk about how, because the dish soap is actually bonding with the fat in the milk, and because that bond is strong, that water and the food coloring are pushed out. So there's a lot of supplies this week and a lot to get through, so have fun.